Hi and welcome to this quick tool review. This time around we have an interesting set of tools sent over from Tangent Engineering. Wait, is this deja vu? I feel like I've been here before. Yeah, we've covered these. That was last week I covered these tools. Why are we back here again? Oh, yeah, that's because before I even got the video out on the review of these really cool sine bars with magnetic bases that fit on your compound, Jim had already worked out a solution and was in production on a tool that I discussed that might be a great option to have when these guys all by themselves won't do the job. And the new tool Jim and his team have designed and already in manufacturing on is the Taper Mate from Tangent Engineering. And this tool works with the sine bars that we've already reviewed. So this guy works when you're trying to not set the angle on the compound, but rather you're trying to set the angle on the work. Because if your compound only has a throw of say like 4 inches of travel, 5 inches of travel, 6 inches of travel, that may not be enough if you need to do a 12-inch taper. So how do you do that? Well, instead of offsetting your compound to an angle, you offset the work to an angle and turn it between centers. Well, that's where this guy comes in, because this guy is a really cool V-block system that'll sit on top of your work, heavy-duty, stress-relieved steel, that will allow you to set one of your sine bars on top of it and set an angle. So you use the clamps that come with it to attach it to your work and then set the angle using the tailstock offset method, which is great for longer tapers if you don't have a taper attachment. Plus, Jim provides in this kit a radius center, which I talked about last time. If you're using a tailstock offset method, using a 60-degree center is not a great approach, because once you start offsetting your work at an angle, the live center that you have sticking in the tailstock is going to potentially damage the work and wallow out that hole and not rotate about center properly. So the radius center drill here can solve that problem. Before we head over to the lathe and show exactly what this guy can do, I need to give you one little piece of errata from last episode, which is these nylon screws. I thought they were for leveling because there were 4 of them, but in truth, Jim put them in here because these magnets are so strong that in some cases it's very difficult to get this off your compound. And you can use these as jack screws to jack the tool off the compound with ease. You don't need to get out an Allen wrench. You can just use your finger and tighten these and jack this right off of the compound and put it away. So for a quick demonstration, you just take the nylon screws and thread them into the holes. So with ease, you can jack your tool right off of the compound, no problem. Using just using your thumb pressure on here, and get them off quite easily. So that's handy. So now let's try setting up for turning a taper without using the compound, but rather using the tailstock offset method. So the first step is drilling center positions. Actually, you can face off the sides here first, which I didn't do. I'm using a piece of aluminum because you can pretty much use any material. But I just had a scrap piece of aluminum. And the nice thing about it is aluminum is non-magnetic, but this will still work just fine. And so I guess the first step would be to face this end off, have it nice, clean and square. Second step will use your radius center to drill a hole. Jim provides a really large diameter one. I have some other sizes here. If you have a smaller lathe and need smaller diameters, you can find these from Jim or from McMaster Carr. So take a look at that. Then you flip the part around, do the same thing on the other side. And you will notice that the center drill hole looks very similar to the regular 60-degree center drill hole, except this one is radiused and the regular one is not. And the beauty is that with the regular one you can go straight in, but this one will support something with 60-degree taper that can rotate at an angle and still not wallow out the whole inside of the hole. Next up, you put your 60-degree center in your chuck, or you may put a center in your headstock directly, whatever the case may be. If you're not putting it in there directly with the Morse taper, then you need to take your compound. You need to set your compound at 30 degrees, which is half of the total 60 degrees, like I showed you last time, and run a skim pass right over this to make sure that it's perfectly centered and in line. That's one side. Then the next side, I'm going to come back here. Let's see if I can get you a good angle here. See what's going on. You can take your tailstock and you can shift your tailstock over. Now, that's one solution, and that works great because then if you have a live center that you're sticking in your tailstock, you're all good to go because you can set your angle and it's turning on bearings rather than rubbing on the internal surface. However, it's always a pain in the butt to get your tailstock realigned. Another solution is to take a boring head that's on a Morse taper that'll fit in your tailstock. I had to use an adapter here because it's Morse taper 3. Pop this guy in your tailstock and then set your offset that way. Let's see, let's go this way. There we go. Now there's a downside to using this method. You're going to have to make, in this case, a 1/2 inch 60-degree center for this guy, and it's not going to be live, so it's going to be rubbing the whole time. If you're doing hardened steel or steel even, you can get away with that with some lubrication for a while, but it's not ideal because you would rather not have the friction and the rubbing on your part. Now, whatever method you're using in the rear here to set your angle to do the offset, it's either adjusting your tailstock off center or use the boring head with a live center part that you make that fits in the end of it. Whatever that method, you put your part between centers, you get your drive dog on here. If you didn't leave extra material for the drive dog to sit on, then don't forget to put some copper or aluminum around to protect your part so that it doesn't get damaged. And then finally, we get to set our taper. Next up comes Jim's fabulous tool. They slotted these so you could slide them on in place, which is really handy. They have long sets of screws and short sets of screws and spacers if the diameter of this part is large. This is fairly small. This is only 1-inch diameter stock. And then you again have screws here to tighten against your part to push it into the V-block. Now again, you know, if you're worried about your part getting marred, toss a piece of copper strip in there, or brass strip. In this case, this is scrap material. I'm not actually worried about it, but why not show good practice? Again, this side does not matter all that much because what's important is pushing this into the V-block. Next, you can rotate your chuck. If I get out of low gear here, it'll be a lot easier. All right, let's see. Flip this guy over. Now we have a flat and parallel to the axis platform to put our sine bar on. We're going to grab the 3-inch sine bar, but it even would support a bigger one. So if you were going to offset in this direction, which is the way my tailstock offsets, set your sine bar, load your blocks inside here, your setup blocks, press it down. The magnets will hold this very firmly in place. Run an indicator. Now you can run it very easily. Pop my indicator on here, and then I can use my cross slide to run the length. And again, I can set the angle to anything I want. A very well done tool. And if you're wondering why this piece is so big, well, you're expecting that if it's going to be much smaller than this, you'd want to use your compound anyways, because the travel in your compound probably would be adequate. Also, the larger size will allow you to use larger sine bars from Jim. So that if you don't have to buy multiple sine bars, you could just stick with one. Either you could stick with this really small one, or let's go up a size and see how they fit. Here it is upside down. You can see that the 5-inch pins fit perfectly on this tool. Pretty wonderfully done tool. Very heavy, very beefy, stress-relieved steel. Did a very nice job machining this. They thought of all the useful features like slotting the clamps so that you could unscrew, put in one side mostly tight and slide the clamp on, and then just bolt down one side, so you don't have to be fiddling with 4 screws. The adjustment screws here to make sure that if your part is fairly small diameter, you can still handle it. This could go even smaller than this 1-inch bar, believe it or not. They did a really wonderful job. So if you're turning taper on something fairly small, this will handle it. Now, my drive dog here, it would be handy if I clamped this in place or used rubber bands to load this in place so that it doesn't move on you, because that's a little irritating, but that's not the fault of this tool. That's the drive dog fitting between jaws on my chuck. All right, so all in all, I give this tool a thumbs up. It is a really fantastic tool. It's really well made. And if you want information about how to get them and you didn't see it at the beginning of this video, check out this information right here. This is all his contact information. Also check out his YouTube channel, because he's got a huge amount of useful knowledge that he shares, and it's worth checking out his channel. He does some interesting animation with CAD that I've never seen before. So all in all, again, a really great product and a really nice add-on to the SINE bar set that works with your compound, and it's going to work on your mill as well with another tool. And I'm even thinking of possibilities of using it on my surface grinder as well. So I'm going to look at, as I discover new uses for it, I'll share them with you. But in the meantime, go check out Jim's channel, and if you like his tools, check them out and get yourself one. It's always great to support a YouTuber, someone with as much experience as Jim that's willing to share his knowledge. It just gives a little back. So thanks for watching. Hope you find it useful. Hope to see you next time.